सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली प्रॉब्लम मिस्ट्री दैट इज द केमिस्ट्री. In previous videos we have discussed about the deep knowledge regarding to the three brothers of the organic chemistry: alcohol, phenol, and the last topic was just ether. Regarding to ether, we have discussed about a lot of things: types, nomenclature, just isomerism, preparation methods, physical properties, and chemical properties. If we'll go with the just chemical properties, then it was 5 types of the properties. So we have discussed still previous video as a 3 properties as a chemical properties. Now the time to discuss about the fourth property, that is the one and only some other reactions also. So if we'll go with the just ether, there are some other reactions also. Other reactions, these are helpful in the interconversion for the NCERT students, means for the just 12th student and the NEET and JEE student. पर्टिकुलर इंटरकन्वर्जन में आप लोगों के साथ में यही प्रॉब्लम आती है क्योंकि आपको छोटे छोटे रिएक्शंस, सफिशिएंट रिएक्शन एनसीईआरटी में नहीं है, कुछ एडिशनल रिएक्शंस भी आपको पढ़नी पड़ती है, तो उनसे आपसे तुरंत फटाफट क्वेश्चंस का आंसर आ जाता है इंटरकन्वर्जन में. सो उसके लिए पर्टिकुलर ये अदर रिएक्शंस इंक्लूड कर रहा हूँ. If we will go with the just other reaction, then first of all we'll take just reaction with CO. CO is your carbon monoxide. Carbon monoxide. If we will go with the carbon monoxide, then this is the ROR. It's a symmetrical ether. This is the CO. Here is the presence of carbon monoxide, and as a catalyst we'll take BF3 as a Lewis acid, boron trifluoride. Approximately we will take 500 atm pressure. 125 degrees Celsius to 150 degrees Celsius will be sufficient for this reaction, and here will formation of RCOOR. Here will formation of ester. If we will go with as a compound, then we can take according to our topic C2H5 or C2H5. This is the carbon monoxide. Under similar condition, BF3, 500 atm pressure and 125 to 150 degrees Celsius temperature. Then here will formation of C2H5. This is the COOC2H5. This is the ethyl, and here is the 3 carbon atom that is called as propanoate, will be as a ester. If we will go with the further reaction, then that is the second reaction, reduction reaction. This is very important reaction. This is the C2H5 OC2H5. Reduction means addition of hydrogen. For this we will take important reducing agent as a phosphorus and HI. We can take important. So this is the phosphorus and HI. You can take red phosphorus also. Here is the 4 of H. One of the H will go with the just C2H5 and gives you C2H6. Another hydrogen with another C2H5, so it will be use of 2 of H, and 2 of H will go with the oxygen. So here will formation of water. Here will formation of ethane as a reduction, by the reduction reaction of the ether. If we will go with the further addition reaction, then we can take dehydration reaction also. So this is the third part as a dehydration reaction. If we will go with this kind of the reaction, then we can say removal of water molecule is called as dehydration. Means water molecule का remove होना अपने आप में dehydration होगा. If we will go with the just reaction, then this is the C2H5. We can write it as follows. It will be much better for us. This is the CS3, CH2, OCS2 and CS3. Here we'll take alumina Al2O3 for the removal of water, and the temperature will be used approximately 360 degrees Celsius. So one of the water molecule will remove like this. From the here it will be removal of H, here removal of H, and this is the oxygen. So here will formation of H2O, rest it will be two molecule of CH2 double bond CH2. This is called as ethene. This is called as ethene. This was about the just addition reactions or some other reactions of the ether also. If we will go with the further, then fifth reaction, that is the very important reaction. Those are known as electrophilic substitution reactions. Electrophilic substitution reactions. These also called as ring reactions. Ring reactions. For these reactions, we will take the example of methoxybenzene, OCS3. This is called as methoxybenzene. It is also called as, according to common system, anisole. This is the anisole. If we will go with the structure of anisole, then this is as follows. Similar with the phenol, we can say, because of or the position of alkyl group as a methyl group, it will hydrogen in phenol. फिनॉल में मिथाइल की जगह आपके पास में हाइड्रोजन प्रेजेंट होगा. स्ट्रक्चर्स किस टाइप से? दिस इज द OCS3 anisole, two of lone pair. These are the two lone pair. Whenever this oxygen atom donates lone pair of here, so in that case particular कार्बन का वैलेंसी 1 2 3 4 ऑलरेडी है, एक और वैलेंसी इंक्रीज हो जाएगी 5 हो जाएगी, दैट इज नॉट पॉसिबल, तो ये पाई बॉन्ड का इलेक्ट्रॉन यहाँ शिफ्ट हो जाएगा. सो द नेक्स्ट पोजीशन ऑक्सीजन ने डोनेट किया है, सो लॉन पेयर आपके पास में यहाँ, दिस इज द CH3, दिस इज द CH3, हियर इज द लॉन पेयर, टू लॉन पेयर था उसमें से वन लॉन पेयर डोनेट कर दिया, सो हियर विल बी पॉजिटिव चार्ज एंड हियर विल बी नेगेटिव चार्ज. ऐसा क्यों? बिकॉज ऑफ जब ऑक्सीजन ने अपना डोनेट किया तो साथ चार्ज पॉजिटिव आ गया, इसने गेन किया तो नेगेटिव. अब ये डोनेट भी कर रहा है तो यहाँ पॉजिटिव पॉजिटिव नेगेटिव कैंसिल, यहाँ नेगेटिव होगा. सो द नेक्स्ट पोजीशन विल बी एज फॉलोज. फर्दर इसने यहाँ डोनेट किया तो ये शिफ्ट हो गया, ये माइनस डबल बॉन्ड OCH3 लॉन पेयर पॉजिटिव चार्ज. फर्दर डोनेट किया तो ये शिफ्ट कर गया, minus double bond, this is the double bond, this is the CH3 lone pair 1 positive charge. अगेन डोनेट किया तो इनिशियल के सिमिलर स्ट्रक्चर बनेगा, दिस इज एज फॉलोज OCH3 with the two lone pairs. So from these canonical structure, these resonating structure, हम क्या कह सकते हैं कि पर्टिकुलर इलेक्ट्रॉन डेंसिटी इलेक्ट्रोफाइल के अटैक के लिए ऑर्थो और पैरा पोजीशन पे इंक्रीज हो रही है. सो वी कैन से दैट ईथर ग्रुप मींस OR और यू कैन से OCH3 इज ऑर्थो एंड पैरा डायरेक्टिंग, ऑर्थो एंड पैरा डायरेक्टिंग ग्रुप मींस ऑर्थो पैरा आइसोमर का फॉर्मेशन होगा. This was about the initial part of the electrophilic substitution reaction. We will discuss about the a lot of reaction regarding to the electrophilic substitution reaction. Go through properly with this kind of this slide. It's so important, as I told you. And this is the last video for the just alcohol, phenol, and ether. So, if we'll go with the examples of the electrophilic substitution reaction, then you have discussed in haloalkane, haloarine, just phenol also, which are the ortho and para-diacting. So, if we'll go with the just electrophilic substitution reaction, then along with the electrophilic substitution reaction, it will be four important reaction. One of the is your halogenation, another is your nitration, another third is your sulfonation, and another fourth important reaction, that is the Friedel-Crafts reaction, which we have discussed in phenol and haloalkane and haloarine also. So these are the electrophilic substitution reaction. This is the electrophilic substitution reaction. Regarding to these reaction, it will be following reactions. Number one is your halogenation. Number two is your, we can say, nitration or sulfonation. Number third is your nitration. Number fourth is your Friedel Kraft reaction, which exists two types of the reaction. One of the is your Friedel Kraft alkylation and another Friedel Kraft acylation. One of the is your alkylation, while another is your acylation, acetylation. These are the two types of the Friedel Kraft reaction. First of all, we'll go with the just halogenation. So it is necessary to remove this kind of the reaction. We'll just will not remove the rajonetic structure because of we have to explain the reaction with the one of the mechanism also. So beam gain same वही procedure होगा. So this is the first part as a halogenation. Regarding to this, we can take the bromination. This is the OCS3 as a anisole. Here is the reaction with the Br2. Here will use of Lewis acid FeBr3 due to increase in electron density at ortho and para position. Here will formation of following compounds. This is the OCS3. This is your Br. This is the OCS3 and this is the Br by the byproduct of HBr. This is the mixture of ortho and para bromo anisole, while para will be as a major product. This is the major product, while ortho will be as a minor product. If we will go with the mechanism of this kind of the reaction, then it will be clear from the mechanism कि particular इसने Br ने कैसे अटैक किया. So mechanism के regarding बात करें, then mechanism exists three steps. Chain initiation step. So first step में FeBr3 octet complete नहीं है. Fe के outermost shell में you can see यहाँ पर्टिकुलर 6 इलेक्ट्रॉन है आउटरमोस्ट शेल में, 2 to 4 to 6, हर एक बॉन्ड में 2 इलेक्ट्रॉन होता है, तो 6 इलेक्ट्रॉन है, इलेक्ट्रॉन डेफिशिएंट स्पीसी है, सो ये लिवाइस एसिड की तरह काम करेगी। इन दैट केस व्हाट विल बी, लिसन मी केयरफुली, वहां आपने यूज किया है Br2, पर्टिकुलर इस FeBr3 के कारण कोई एक Br बॉन्ड के दोनों इलेक्ट्रॉनों को विड्रॉ कर लेगा, माइनस चार्ज हो जाएगा, होमोलिटिक नहीं होगा। अगर ये नहीं होता तो एनवायरमेंट होमोलिटिक होता, बट ये प्रेजेंट है तो हिट्रोलिटिक होगा। सो हियर विल फॉर्मेशन ऑफ FeBr4 minus and here will formation of Br plus एज ए इलेक्ट्रोफाइल, ब्रोमोनियम आयन का फॉर्मेशन होगा। पर्टिकुलर नेक्स्ट स्टेप में चेन प्रोपगेशन में यहां आपने लिया है एनिसोल, दिस इज द एनिसोल, और एनिसोल की कंडीशन ये बता रखी है कि ये ऑर्थो और पैराडाइक्टिन ग्रुप होगा। सो इलेक्ट्रोफाइल की फॉर्म में Br प्लस अटैक करेगा इलेक्ट्रॉन रिच सेंटर्स पे, एंड इलेक्ट्रॉन रिच सेंटर्स आर जस्ट योर ऑर्थो एंड पैरा, दोनों पोजीशन पे अटैक करेगा साहब। दिस इज द Br, these are the 2 lone pairs and this is the Br, दोनों पोजीशन से रिमूवल होगा हाइड्रोजन का। दिस हाइड्रोजन फर्दर इन चेन टर्मिनेशन स्टेप reacts with the FeBr4 minus, so this is the FeBr4 minus with the H plus, here will formation of FeBr3 again with the byproduct HBr, this is the HBr, एंड FeBr3 जितना पार्टिसिपेट कर रहा है उतना बन रहा है, सो ये अपने आप में एक कैटलिस्ट की तरह काम करेगा। दिस वाज अबाउट द जस्ट मैकेनिज्म। यहाँ ये अपने आप में एक इलेक्ट्रोफाइल, इलेक्ट्रॉन लविंग स्पीसी के रूप में अटैक कर रहा है सर, दैट्स व्हाई इट इज कॉल्ड एज इलेक्ट्रोफिलिक substitution reaction. This was about the just first part as a halogenation. Now the time to discuss about the second reaction, that is the sulfonation reaction, and for the nitration and so on. So listen me carefully because of its very important property. इंटरकन्वर्जन में प्लस रिएक्शंस में भी आपके पास में काफी क्वेश्चंस यहां से मिलते हैं। एनसीईआरटी का मैक्सिमम आपसे सिलेबस डिस्कस कर रहा हूं लाइन टू लाइन, टॉपिक टू टॉपिक, सो बी इन गेम। So this was about the first part as a halogenation. Now we'll go with the just second part, that is the sulfonation. What is the mean of sulfonation? Just sulfonation, substitution of sulfonic group. For this is the anisole OCS3. This is the concentrated H2SO4, like this. We can write it as follows: OH minus SO3H plus as electrophile. Here will attack of H SO3H plus. So here will formation of same ortho and para isomer. We can take over here. This is the OCS3 and this is the SO3H As a byproduct, here will formation of H2O. Both are known as O and P methoxy benzene सल्फोनिक एसिड का फॉर्मेशन होगा बिकॉज ऑफ यहाँ सल्फोनिक एसिड ग्रुप की ज़्यादा प्रायोरिटी है while it acts as a prefix also. So this was about the sulfonation. If we will go with the third part, then that is the nitration. Nitration, substitution of NO2 plus group. For this, we will take just anisole OCH3. This is the concentrated HNO3 in the presence of concentrated H2SO4. Concentrated H2SO4. So here will formation of O and P nitroanisole NO2. This is the, you can take bond and circle both. So this is the OCH3 NO2, and here will removal of the H2 as a byproduct. Here is the O and P nitro, O and P nitro anisole will be as a just main product. Same O will be as a minor and P will be as a major product. Same with the minor and P as a major product. Major product. If we'll go with the further, then it's your Friedel-Crafts reaction, and first of all we'll go with the alkylation reaction. So this is the fourth. We can call it Friedel-Crafts reaction, and regarding to it, first of all we'll go with the alkylation, substitution of alkyl group. For this again it will use of the Levi's acid. So this is the suppose anisole, this is the methyl chloride. For this we can take anhydrous AlCl3 as a Levi's acid. बॉन्ड का क्लीवेज हेट्रोलिटिक होगा, होमोलिटिक बॉन्ड क्लीवेज नहीं होगा. Cl minus will attack over here and it will be formation of the electrophile CH3 plus जो कि पर्टिकुलर ऑर्थो और पैरा पोजीशन पर अटैक करेगा. OCH3, this is the CH3, this is your OCH3 and this is the CH3. Rest it will formation of the, we can say, removal of the HCl. HCl का रिमूवल भी होगा बाय प्रोडक्ट की फॉर्म में. सो दिस इज द O and P मिथॉक्सी टॉलुइन का फॉर्मेशन होगा. सेम ऑर्थो एज अ मेजर, सॉरी माइनर, while para as a major product. This is the major product. This was about the just your Friedel-Crafts alkylation reaction. We'll go with the just acylation or acetylation reaction also. Go through properly with this kind of the slide. If it is not visible, then it's major. It's a major. I'm going to write here major product. Now the time to discuss about the final reaction, that is the Friedel-Crafts acetylation or acylation. Both are same. It will attack of acyl group as a electrophile. What is that? Listen me carefully. The second part is it was the alkylation. Now this is the Friedel-Crafts acylation reaction. Acylation or acetylation reaction. For this, we can take, as we have discussed in many of previous videos, acylation के लिए आप या तो acetyl chloride का यूज कर सकते हैं, or you can use acetic anhydride also, CH3COOCOCH3. Then what will be? In the presence of same anhydrous ALCl3 as a Lewis acid, so here will formation of like this CH3CO plus and Cl minus. This is the minus and CH3CO plus. This is the OCH3, COCH3. This is the OCH3. This is the COCH3. अगर आप particular CH3COCl use करें, then it will remove all of the HCl. And if you are using acetic anhydride, then it will remove all of the CH3COOH as a byproduct. This will be as a minor ortho. This will be as a major product, para, major. And both are known as ortho and para methoxy acetophenol, because ketone का ये carbon countable होगा, so it will be as acetophenol. So this was about the just electrophilic substitution reactions of the anisole. So dear doctors and engineers of the near future, will meet in the next video. Till then शुक्रिया, धन्यवाद, यही अपना प्यार सपोर्ट देते रहिए. फिर से मुलाकात होगी एक नए टॉपिक के साथ में. तब तक के लिए अगेन धन्यवाद, शुक्रिया.